Okay, 5-4b, there's a lot to do here, so I'm just going to hop to it. All right, so determinant, the determinant is a characteristic of a matrix. So let's just write that down. A determinant, this is a characteristic of a square matrix. Okay? Now, there's a formula that we get. So I'm going to just start with the formula and do an example. And then I'm going to give you the formula for a 3x3 and do an example. Right? And one other thing that we need to know about determinants, note, the answer is just a number. Okay? When you find a determinant, you're finding a number. I'll say it again. When you find a determinant, you're going to find just a number. All right, so let's take a look at the determinant of a 2x2. So here it says A equals A, B, C, D. And notice that the brackets have the regular brackets. This is the matrix, okay? Then we could say that the formula states this. It says the determinant of A is, and now they go straight bars, A, B, C, D. So notice how they have straight bars, right? There's a bar here, bar here. That means I'm looking for the determinant of the 2x2 matrix.
Ms. Adgers, Ms. Miller, Ms. Moss, Ms. Perez, could you dial 7114, please? Ms. Adgers, Ms. Miller, Ms. Moss, Ms. Perez.
Somebody dial it for her.
7114. Thank you.
All right. So in order to find the determinant of a 2x2, I think about this. Honestly, I like slashed it with swords, so that it's going to go diagonal this way, and we're subtracting. So A times D minus these guys here, so B times C. So I think about it like going diagonal this way minus diagonal this way. All right, so AD minus BC. That's it, okay? So let's do an example. The directions are going to say something like, find the determinant of, and then it's going to say A equals 4, -3, 5, and 1. All right, so we're going to find the determinant of this. All right, so I can start that off. The determinant of A is 4, -3, 5, 1. So 4 times 1, so 4 times 1 minus 5 times -3. Clean that up a little bit. 4 times 1 is 4. -5, -3 is a positive 15, and my answer is 19. I get a number. All right, let's do another example here. I'm going to skip all of the niceness here. Let's go with 5, 7, 3, 5. Let's find that determinant. The determinant of this guy is going to be 5 times 5 times 5 minus 7 times 3, which gets us 25 minus 21, and I get a 4. Okay? So that is finding the determinant of a 2x2 matrix. The determinant of a 2x2 matrix. Now, the determinant of a 3x3 matrix, a little bit different. So, determinant of a 3x3 matrix. It's called a determinant because it determines something. This is going to determine whether or not we can have an inverse matrix, and we'll deal with inverse matrices in 5.5, excuse me. So just right at this point, I want you to just get used to the idea of finding determinants in 5.4. That way, in 5.5, whenever we get to inverse matrices, we can just use the determinant quickly to determine if we even have an inverse matrix. All right, so here we go. The determinant of a 3 by 3 matrix. Note, it follows a pattern that was provided to us. So plus, minus, plus, minus, plus, minus, plus, minus, plus. All right, so we were given this pattern, and I don't know who gave it to us. I don't know where it came from. All I know is that this pattern helps me a ton when it comes to finding the matrix. So I'm going to let matrix A equal A, B, C, D, E, F, G, H, I. That's it. Okay? Now, here's where we're going to use this little pattern that they gave us up here. So, the determinant of this matrix A would what we're going to do is we're going to multiply this guy as a scalar, and I'm going to get rid of the row and the column that's with it, and I'm going to multiply it times the determinant of the leftovers. So here we get, so this whole thing equals A, and A is positive, so another way of thinking of that is that A, it's the same sign as A times the determinant of the leftovers. So E.
If you're on second hour plan and willing to help me out, give me a call at 7114. Again, if you're on second hour plan and willing to help me out, please give me a call at 7114.
Then we're going to circle B here, this next term, and it's the opposite sign of B, and I'm going to take out this top row, take out the middle column, and my determinant of the leftovers, D, G, F, and I. So it's going to be minus B times the determinant of D, F, G, I. And then finally, C, this guy here, it's going to be the same sign. I'm going to take out this top row, far right column, and I'm going to use the determinant of the leftovers here. So same sign as whatever it is, so plus C times the determinant D, E, G, H. So D, E, G, and H. Now, we could take this a step further, right? I could go through the whole process of just doing these. Actually, I'm just going to get to an example, right? I'm not going to go any further into the this formula. Yeah, you know how to do a 2 by 2 determinant of a 2 by 2. I want to show you how to use this guy. All right, so let's get a random, -2, 3, 4, 1.
Miss Neely, could you call 7114, please? Miss Neely, could you call 7114?
All right, so we want to find the determinant of this guy. The determinant of this matrix, we're going to follow this pattern here. All right, so I'm going to take the first spot here, same sign, so I get -2 times the determinant. Take this row and this column out, 6, 5, 2, 3. So 6, 5, 2, and 3. And then minus B, so that's this one here. So I want the different sign, so I can put 3 here. And then take that row and that column out, and we get 1, 5, 9, 3. So 1, 5, 9, 3. And then plus 4 times the determinant of these leftovers. Take that row and that column out, 1, 6, 9, and 2. So 1, 6, 9, and 2.
Teachers, at this time, could you please check your email about the ACT and follow the instructions? Please send the students to the auditorium even if they don't have a ticket. Again, please check your email for the ACT instructions. Thank you.
All right, so then we get -2 times the determinant of this, 6 times 3, 18, minus 2 times 5 is 10. Minus 3 times this determinant. 1 times 3 is 3. 9 times 5 is 45. Plus 4 times the determinant here. 2 minus 54. And now I take another step. Just the inside parts. 120 minus 208 is a negative 88. So the determinant of this 3 by 3 matrix is negative 88.